Hi, good morning, guys. Good morning, good afternoon, good evening. I hope all of you are very safe and healthy. Okay, so I'm back again with this video series that we were planning to develop a complete REST API with AWS Lambda and PostgresSQL. Okay, so this is part one of this series. Okay, and if you have not watched part one, this is part two of this series. If you have not watched part one of this series, this I would recommend please go and watch part one of this season itself so that understanding the what I'm going to explain in part two will be easy and smooth for us. Okay. So in part one, I'll just give a brief about that, what we have covered in part one. In part one of this video series, we have completed these many things like on AWS console, we have created a PostgreSQL database instance with Amazon Aurora database engine. And Amazon Aurora database engine is known for serverless database instance creation for MySQL or PostgreSQL. Okay, so with that we have created PostgreSQL database instance on Amazon console itself. Okay, with Amazon Aurora database instance database engine. Okay, and we created a database there. We created a database called sensor data, and after that we have created a database table there that was registered data. Okay, and we have inserted few sample records within that table itself. Okay, so that was part one. Okay, and in this series, the part two of this session, what we are going to cover, we are going to develop a REST API that we will write in C# .NET Core in Visual Studio, and we will leverage AWS Lambda function in order to publish that API to Lambda environment. Okay, and what this API is supposed to do, this API is supposed to develop, supposed to connect to this PostgreSQL database instance that we had created in part one of this video, and will post few records from the API, and that will be get inserted into the database. Okay, so that is the agenda of this video today. Okay, so let us start. Uh, yeah, in order to complete this demonstration, these are the prerequisites. Okay, that we must have a free tier AWS account. That is the primary one. Our local system should be authenticated with AWS account credential. Thirdly, we should have the knowledge of AWS Lambda. Okay, so for this AWS Lambda, I have created a separate playlist of AWS Lambda that is dedicated to AWS Lambda itself. Okay, so I would request please go and watch that playlist. Okay, so that you have a good understanding of AWS Lambda before this session. Okay, I will put the link of that playlist in the description of this video itself. Okay, and we have .NET 8 SDK installed in our local machine also. I will put the link of .NET SDK also in this video description of this video. Okay, we should have Visual Studio 2022 should be installed in our machine. Okay, or our AWS CLI should be configured for in our local machine. Okay, so that is another prerequisites. Okay, and there is AWS Toolkit extension that also we need to install in Visual Studio. Okay, so installing this toolkit extension is the extension from AWS that is supported in Visual Studio 2022 will be installed, and it provides the SDK to for the AWS services. Okay, development application development with AWS services. It provides all those supports with Visual Studio. Okay, so all these are the prerequisites of this demonstrations. I will put the reference links for all these prerequisites in the description of this video. Okay, so that you can go through and get that machine ready. Okay. Yes. So yeah, let us start the demonstration. What we will do, we will create a API project in Visual Studio. Okay, with AWS Lambda. So let us jump into the Visual Studio itself. Yeah, I'm in my Visual Studio. So what I'll do, I have a solution here. Okay, I will create a new web API project. Okay, I'll select this template ASP.NET Core Web API, or you can find from here also. So I'll select this template ASP.NET Core Web API template itself. Clicking next. You can give a name as per your choice. Lambda API demo with Postgres. I'm giving this name itself. Okay. I'll save this. I'll save this in D drive, Lambda API demo with progress in this Postgres. In this directory, we will save the project. Clicking next. Okay. And all these things are fine. .NET 8 framework, authentication type, none we will select as of now. And we will enable the Open API for Swagger support. Okay. And we are not using controller as of now. Instead, we will use the minimal API. Okay. And clicking create. So our project API project is ready now. Okay. Let us run it. Let me make it startup project. Okay. And build it. Build is successful. Okay. Let us run the project now. So our API project is running. Okay. We have this default endpoint weather forecast. Okay. And let us try this. It is returning the default sample data that is already written in this template itself. If we can see in the program.cs, we already have an endpoint with some sample JSON data, and this endpoint is returning this data. Okay. So very first, what we will do, we don't need this. Let me stop the project first. We don't need this segment. Okay. We don't need this endpoint itself. Yes. So we don't have any default endpoint in this project now. In order to make this project compatible with AWS Lambda, what we have to do, we have to install few important packages from NuGet. Okay, so we'll go in the NuGet package. Okay, and here we will search for Lambda hosting. Okay, you will find this package Amazon Lambda ASP.NET Core server hosting. We need to install this package. Okay, let us install this. Okay, this package is installed. Okay. And after this, we need to make few changes in the program.cs. We need to insert a line here, builder.services dot add AWS Lambda hosting. Lambda hosting event source will be HTTP API. Okay, so this line is important. Builder.services dot add AWS Lambda hosting. Okay, and Lambda hosting event source will be HTTP API. So the trigger will be HTTP API for the Lambda execution. That is the purpose of this statement. Okay, after that, in the project file, we need to add an item here. AWS project type, that is Lambda. Okay, so entering this line, convert this API project to the Lambda project. Okay, and after that, due to this entering this line here, we will get this option here, publish to AWS Lambda. Okay, so that we can publish this project to AWS Lambda environment. Okay, so this option has been enabled by entering this statement here. Okay, so that is it. And what we'll do now, in the program.cs file, we don't have any endpoint as of now. So we will write our business logic that will connect to the database and will insert the records from the API to the Postgres database itself. Okay. So in order to save the time, I have already written that logic. I'll just put that logic here and we'll explain that complete business logic one by one to you. Okay, so let me copy this statement here. Okay, so in our program.cs file, before app.run, we have to put this logic. Okay. So, and we have two model here, the input model and the response model, that also we will copy. That is here itself, two model class. That is the input model, that is the register data, and the response model. Okay, I'll copy this two classes also, and we'll put that outside the main class, main function program class itself. Okay. Yes. So the code block is ready, and this method add bulk register data sync. This method also we will require. So this method is also written here. We will copy this method also. And in the main program class itself, after the main method, we will put this method itself. Okay. So we have our business logic in place. Okay. Still, we need to add few more packages. So this is, we are connecting the Postgres database. So npg-SQL, that is a package that we need to add in order to communicate to PostgresSQL database. So we will go again on NuGet package. We'll select this npg-SQL. We'll install this. The latest version is 9.0.2. Let us get it installed. Okay. Yes. So this package is also installed. Now we can see this. Yes. And so in the program.cs file also, we need to reference the namespace using npg-SQL. Okay. And npg-SQL types. Okay. Yes. So now there is no errors in the project. Let me build this project itself. Let us see if there is any error. Okay. Project is successfully built. There is no errors. Okay. Let me explain you the business logic, what this block of code is doing itself. Okay, so we have this default endpoint. Okay, once we will deploy this function to AWS Lambda, we will get the function. We will create a function URL that will be the base URL of this API. And once you will hit that URL, you will get a default message, hello from AWS Lambda. Okay, that is the we are mapping a get method here, the default route. And after we have another route here, that is sync data. We can make it any, you can give it any name. You can give it post data or send data, something, whatever you like. You can specify the endpoint here. And we are creating this as a post API. So this is sync data, and we're getting a JSON array of register data. Register data contains this array. Okay, so one item will have the register ID, device date time, device raw reading, okay, normalized value, data quality, and the server date time. Okay, so all this property will be there in one register data. We will pass the array of register data within this endpoint itself here. Okay, so that will be the input, and this is the context, the HTTP context itself. In order to read the API headers, whatever header information we are passing and the API details, in order to read that property, we are passing this HTTP context object itself. Okay. So what this block is doing, it is just checking first, like whether the list of register data is not empty. Okay, if it is not empty, then it will go inside. Otherwise, it will return a error message here that there is no record in the request. There is no input record available in the request, something like that. Okay. So the for default message we will return and we will come out. If the list contains any records, okay, there are few register data within that API input itself. Then after it will come within this block here, and it is checking an API key also. Okay, so we will do a validation also. It is a kind of authentication, so that our API is not being exploited by some different source. Okay, we will place an API key in the Lambda environment, and we will pass the API key from in the header of the API, and within this logic, that API key will be validated. If the API key what we are passing in the request is equal to the API key that what we have defined for this API in the Lambda environment, if both are matching, then only it will allow to execute the further logic. Otherwise, it will return an unauthorized message. Okay, so this is that block. If we are calling the API with a valid API key, then after we will read the connection string. Okay, so connection string we are also calling from AWS Lambda environment. Okay, so in the AWS Lambda we will define few environment variables. One will be the API key, a valid API key we will write there, and the database connection string also. Okay, so this value of these variables are being read from the environment variables. After reading the connection string, we'll pass this connection string and the input list to this method. Okay, add bulk register data string. Okay, the whatever input array, the array of register data we are passing. Okay, that we will put inside this method. Okay, let us see what this method is doing inside. Okay, so what this method is doing, it is we are creating a response object. What we are supposed to return from the API, and after that we are doing some validations whether list has some records itself or not, whether the connection string is proper. Okay, so all these validations we are doing, and if all these two validations are being passed, after that we are creating a PostgresSQL connection object here, and we are trying to create the connection. Okay, and we are checking if the connection is opened properly or not. Otherwise, it will keep on waiting here in this block. After that, once the connection will be open to the database, it will come out here and will create what we are doing here. We are just making a bulk request, bulk insert, okay, to this table, register data table. Okay, so I'll show you the table structure also. This is the server instance I have created. Okay, and in the database I have created this. We had created all this in the previous part 1 also. Sensor data database we had created, and after that we had created a table here, and table register data. It contains these columns, that register data, device date time, raw value, normalized value, data quality, and server data. So all these column names we are passing here in the sequence: register data, device date time, register data, device date time, raw value, normalized value, data quality, raw value, normalized value, data quality, and the server DTM itself. Okay, server DTM, and creating a writer object here with this statement, and we are getting a current date time in a variable here, and looping through the register list. Okay, and writing to the writer. Okay, like register ID, raw register ID from the item. Okay, that is the integer. It is integer type here. Okay, you can see the properties here. Okay, let it open. Okay, so device ID is also integer. and device date time, that we will pass in the list itself. That is will be the date time object, date time type of date time itself, and raw value, that is numeric, normalized value, that is also numeric, data quality integer, and the current date time what we have created when we are inserting the data to the database, that is the current date time. Okay, so it will furnish the writer object, and finally we are completing the writer object. Okay, so this is the process of writing bulk records to PostgresSQL database. So we are making a bulk record, bulk insert. Okay, once the writing is complete, we are closing the connection. Okay, and returning a successful response to the user, like sync state is equal to true and sync state message. This is the two property of the response object. If you will see here in the response object, okay, we are returning a flag whether it is true or false, or we are following with a message, the sync state message. Okay, so that it is doing here that the following number of records successfully saved into the database, something like that, and returning the response object. In case there is any error in this block, we are handling the exceptions, whether it is failing to connect the database, okay, and validating the duplicate keys and all, or any other exceptions. Okay, so we are handling all these responses and returning the appropriate response object to the user. That is the quite simple business logic here. Okay, so what we have to do, we will first, there are two things, like we need to define these two environment variable. First is API key, and second one is the database connection string. Okay, and that's it. So what we will do, we will first deploy this method to this project API to AWS Lambda. So let us first deploy this. Okay, the name of the function will keep same as Lambda API demo with Postgres. You can give any name of your choice. Okay, but I'm just giving the name of this project itself, or Lambda API demo with Postgres. Okay, I'll copy this, and in the handler part also put the same name here. Okay, and let me move next. Okay, default execution role. Okay, that is we need to select a execution role in order to deploy any Lambda function. Okay, this is part of my Lambda video series. Okay, so you can go through the video series and you can better know about the what is Lambda execution role itself. Okay, so we'll select the Lambda execution role here, and let me upload this. Okay, so it has been deployed to Lambda environment. Let us verify this whether it's deployed properly or not. I'm on AWS console itself, and in my Lambda console. Okay, so all services, all services. I'll search for Lambda, okay. And see this function is here. Lambda API demo with Postgres. Okay, Lambda API demo with Postgres. So this function is available in my Lambda console. Okay, yes. Now what we have to do, we have to create a function URL for this function. So we'll go in the configuration and function URL, and we'll create a function URL here. Okay. Authentication type, I'm not using any IAM authentication of now. I'll keep it none, and we'll save it. We have this Lambda URL. Okay, let us copy this Lambda URL and put here. Let us hit this. So we are getting this default message, hello from AWS Lambda. That is the default endpoint of this method. So we have seen that default endpoint is working, but what about the sync data? Okay, so sync data, in order to We have enabled the Swagger also. Okay. So let us see if Swagger is working here in this endpoint. See, the Swagger is not working. Why this is Swagger is not working? So it is because we have we are doing this check here. If the environment is development, then only this Swagger UI will appear. Okay, so for this to enable the Swagger, what we have to do, we have to go here in the environment variable. We'll edit this. We'll add an environment variable here, and ASP.NET Core ASP.NET Core environment. Okay, and it will be value will be development. So let us save this. And also in the same place, we will add another uh, environment variable also. That is this connection string. Okay, and the value of the connection string will be the connection string of the database. Okay, so what is the connection string of the database? We have that. Okay, in the last time when we have in the part one, when we have created this database, we got the credentials saved. So this is the connection string of the database itself. Okay. Let me explain you about this. Yes, so server is equal to database one, the name of the endpoint itself. The port number, that is the default port of Postgres. Database name is equal to sensor data. User ID, default user ID of the Postgres, that is Postgres itself, and the password that we got when we created the database itself. Command time, where timeout we have given some value. Okay. If you want, you can exclude that also. No worry. Let me copy this and we'll put here in the dbcon. And another environment variable that we need, that is API key. Okay. So for the API key, we will give a random value. Okay. So let me generate a GUID itself. Okay. So I'll keep this as a API key. Okay. And yes, let me save this. Okay. So all these three environment variables I have declared here: the environment itself, database connection string, and API key. And we can see in the code block itself, we are calling these environment variables here in this place to validating the API and database connection string. Okay. And let us save this. Okay. So now give it a few seconds. And I hope this Swagger should work here now. Yes, we got it. Okay, so we can see this Swagger is up and running, and we have this method sync data. Okay, and let us try this. Register ID 1, device ID 1. Okay, date time. Let me pass a date time here, 2025 January, and today's date and today's time also just now. It's 22:20. Raw value 45 dot something. Normalized value, let's round up the 45 raw value itself, 45.57 something. Data quality will be good, and server DTM same time. Okay. Let me verify first whether there is any record in the database, in the table. There is no record here in this table. And let me execute this. Okay, let me add few more records. Okay, so register ID 2, device ID 2, and it is 21, and let me modify the value also. 45 and 5 itself, 45 point something. Okay, let me copy this. Yeah, click execute. Okay, it is returning unauthorized. We better know why it is returning unauthorized, because we are hitting the API directly. We are not passing the API key here, right? So that is the reason it is returning this block. Okay. So we will try this API with. Let me open the Postman. Postman is a tool where we can validate our API. Okay, so I'll create a phrase collection here. New request. Demo API. It will be a post API. This is our endpoint. No, this is not the endpoint. Okay, endpoint will be. What will be our endpoint? Endpoint will be this one. Sync data. Sync data. Okay. And in the body, we will put this input array. Okay. We are inserting 2 records. And in the header section, we will add this API key. Okay. So this is the attribute API -key we are passing. Okay. And in the value, we will pass the API key that we have for this API. Okay. Now, let me try this. 2 records inserted successfully. Okay, first time it will take time, because that is because the cold start of the Lambda function, that is the cold start behavior. After that, subsequent request will be very quickly. So it has inserted 2 records into the data table. Okay, let us verify in the Postgres itself whether records are inserted or not. So let me select this and execute. Records are not inserted. Okay, let us know why it is happening here. So let us connect this database again. Okay, I think let me remove the server. Okay, we'll create a new server here. Post this. In the connection, we will give the connection detail, that is this server ID endpoint itself. Okay. Default port is 5432. Username is Postgres, and the password is this password. Okay, let me save this. This is sensor data. Okay, in the schema, within public schema. Let me view this table itself. Yes, okay. That was something different database was connected. Okay, so this table has two records. The value we have inserted these values 45.56454. We can verify this value, and 45.57, that is the normalized value. And the second one, this 44.56454 and 45.2524 is the normalized value. So that is it. We are using this Lambda function and this method as an API, complete API. Okay. So that was the demonstration, the agenda of this video, that we have completed a REST API. And like this, this is not limited to the PostgreSQL database. In the same way, we can develop this kind of serverless API with AWS Lambda, connecting to any database, let it be MS SQL, MySQL, or the PostgreSQL, or the DynamoDB itself. Okay, any kind of database you can connect. Okay, the only difference will be the logic, or the differential code that we need to write accordingly as per the connecting database itself. Okay, and all this logic is our used to logic that we are using to connect to the database and posting the records. Okay, so that was a small demonstration how we can develop a complete REST API with AWS Lambda. Okay, and that is two serverless API, because as we can see, we have not created any EC2 instance or the virtual machine, okay, on AWS. Okay, it is running on the AWS Lambda environment. Okay, and AWS Lambda is completely serverless. Okay, and even the database we have created in the RDS, that is also in the serverless. We have that serverless instance with Amazon Aurora. Okay, so that is all about this section. Okay, if you have any doubt with this topic, if you are trying to do this activity or this demonstration on your local machine, and in case you face an issue or the problem, you can reach out to me in the comment section of this video. Okay, I'll be very happy to help you and assist you. Okay, thank you guys. Thank you very much for this video, for joining this session. Okay, and if you find this session more informative, please like the video and subscribe to our channel, so that you will automatically get notified for all of my upcoming videos, for such any interesting video that we are planning to upload in the channel. Also, this is also required to motivate us, because if you like and subscribe the channel, that is really motivating the team to upload more interesting videos like this. Thank you very much, guys. Thank you very much.